So the question asked about a pretty interesting system where at a carnival, basically, there's kind of these rocket-shaped cars that hang from this large steel disc. And this steel disc spins around in a circle until the cars create a 20-degree angle from the vertical. And basically, these carts are hung along chains, and the question wants to know what is the speed of these cars. So here I have a picture. This is the top-down view of what it would look like. Here is the metal plate spinning around, and each one of these are like car rockets. And this is what it would look like from a sort of kind of side view right here, where this is the toy rocket and it's spinning in a circle, where there's this tension value here, and it forms an angle of 20 degrees. So per each kind of rocket, we'd see this sort of force diagram where tension goes in this upward direction, and this and one component of it is centripetal in the centripetal direction, while the other component of it kind of is against gravity and makes the vertical net force 0. So some learning objectives and context in this question would be that one learning objective is to use free body diagrams, which is a very, very key kind of thing in this class in learning forces. Another learning objective here would be the centripetal force, or well, a force in the centripetal direction. And there is a very, very good case of it here. And finally, one of the forces, tension. To solve this problem, we first need to find the radius so that we can use the centripetal force equation. So to find the radius, we need to find basically this horizontal component of the chain that it sort of makes as it kind of goes out, right? So this ends up being a 6 sine 20, doing a little bit of trig, opposite over hypotenuse, and we get 2.05 meters. And basically we need to add this to the radius of the inner disk, which is 2.5 plus 2.05, which eventually comes out to be 4.55 meters as a radius. So knowing this, we can actually use our equation up here, mv squared over r, and we can also sum the mass, not sum the masses, but sum the forces. So here we can isolate for velocity, and this is going to help us a lot later on. So doing a little bit of algebra, we can actually sum the masses and algebraically solve for the tension value. So right here we have t cos theta minus mg equals 0, because we know that the vertical force is 0. Well, the net vertical force is 0. And then we can get the relationship of t equals mg over cos theta. And then knowing this, we can use this mv squared over r equals tension sine theta, because that's the component, this component right here, sine theta, that is going towards the centripetal direction, the radial direction, and we can solve for Fc, which we get the Fc value of mg tan theta. And then knowing this, we can actually plug it into the equation before and plug it in right here. And then all of a sudden, we have enough information and we know the numerical values for all of the variables we can solve for. So the m's cancel because we do not know m, which works out perfectly. And then plugging in some numbers here, like 9.8 for gravity, 20 for the degrees, and 4.55 as solved for above here, we get the velocity of 4.03 meters a second. Now, two common mistakes in this problem are not accounting for the additional radius that is caused from the horizontal length of the string, on the car, and the second one would be not correctly summing forces. Thank you.